Hello and welcome. I am Ratna, your host for the day. Welcome to an informative webinar by ITTStar, organized in association with Amazon Web Services. Let me give a brief introduction about ITTStar. ITTStar is a customer-focused business that has been delivering software solutions to businesses globally. The company specializes in digitalization of business assets using data analytics. In today's session, we will discuss an effective platform that helps you make sense of the massive health data at your disposal. Amazon Healthlake. Healthcare data is becoming increasingly digitized, like in other industries. It is growing not just in value, but also complexity. A successful health data management solution must be able to derive sensible outcomes from this data and manage it to benefit healthcare organizations, practitioners, and ultimately patient well-being and health. Amazon Healthlake is such a solution from Amazon Web Services, which uses the latest technology of machine learning to derive meaningful conclusions from the available health data. Here is a little brief about AWS. It is the world's most comprehensive and broadly adopted cloud platform, offering over 200 fully featured services from data centers globally. Amazon Healthlake by AWS helps extract meaning from unstructured data efficiently and makes predictions from large volumes of health data. You will get to know more about this platform as this session progresses. Let me introduce the day's speaker, Harvey Ruback from AWS. Hello, Mr. Harvey. Welcome to the session.
Thank you very much.
Mr. Harvey Ruback is a senior partner and solution architect at AWS. He would give us more insights on what makes AWS Healthlake an ideal choice for health data management. And second speaker for the day, Nitin Das. Welcome, Nitin.
Hey, hi, Ratna. Hi, all. Thank you.
And the third speaker we have with us is Prithvi Kumar Reddy. Hi, Prithvi.
Hey, hi, guys. Thank you.
Hi. Both Nitin and Prithvi are data engineers with expertise in artificial intelligence and machine learning. Before we begin, let me also welcome our dear audience. Thank you for joining us today. If you have doubts about the discussion, feel free to raise them in the comment section. Our experts will be answering your queries. Now let's begin. Over to you, Mr. Harvey.
All right, thank you very much. Let me get my screen shared here. So thank you for the introduction. Again, my name is Harvey Ruback, and I'm a partner solution architect in the healthcare and life sciences vertical. What this means is that I mainly work with AWS partners such as ITTStar here, and I focus on those partners that are working within or developing solutions for the healthcare and life sciences industry. And today I'm going to give you an overview of Amazon Healthlake. So if we step back for a minute and we look at the state of healthcare data today, and we know that historically we have lots of patient data that's been collected over decades. And all of this data is today, it's mostly siloed, meaning that it exists in individual data stores, databases, potentially even just medical records sitting on shelves. And that data is not in a place or organized in a way where it can all be brought together, right? And a lot of the important data is unstructured. It sits in clinical notes. It sits in the notes that doctors take during sessions, and it's unstructured. It's not in a nice column format. It's not normalized across clinics, industry, networks, and such. It's free form text. Now, technology exists to help address all of these different things, but as always, skills and resource constraints from a business perspective make it hard to go and attack each of these data problems individually. And as a result, we cannot make actionable insights on this plethora of healthcare data that we all have access to. And in addition to that, as patients today, as medical digital devices become more and more prevalent, we're generating exponentially more data than we did in the past, whether it's exercise step counts, logging what we eat, health monitors that are looking at our blood pressure, our weight, maybe even tracking our heart rate during exercise. The amount of this data is it's growing exponentially. And so given that and how healthcare priorities have evolved recently, especially given the pandemic, we have this growing need to create actionable insights on this data. Actionable insights meaning the ability to look at this data, infer something about the patient, the population, and then be able to do something with that information to improve a patient's overall health, bring more healthcare to a subsegment of the population. And as you can imagine, to do that, having a complete view of each patient, meaning a 360-degree view, a longitudinal patient record, a collection of data that spans the full breadth of the individual patient or the full breadth of a population, so that we can make decisions holistically across the board, right? Not just looking at segments of the data, right? The other thing, other challenges is we need to shorten the life cycle. There's this big demand to be able to identify a problem and implement and bring a solution forward as quickly as possible, not only from a technical perspective, but for the individual patients and populations as well. And as this need to gather more data and put it into a format, structure it in a way that can be used by these AI systems that are developing, we're putting more and more pressure on the clinicians, the caregivers, the nurses, the full clinical staff to record all this data and bring it all in, which is pulling those clinicians away from what they really like to do, which is spending time with their patients, right? And we need to capture more data. We need to put it in the system in the way that we can use it more. And what this all results, where it also comes around to when we talk about populations, is this equitable access to care. Whether you're someone or a group of people that lives in a rural area where you don't have access to the same choices for medical care as people that live in denser urban areas, or whether you live in a denser urban area, but for economic reasons or just work-life balance reasons, you don't have the ability to access that care. So there's a big drive, a big demand to identify these groups and find ways to bring them the care more easily, and also identify people in population subgroups that need the care that aren't able to get it today, right? And from an AWS perspective, to help address some of these needs, we have a set of what we call purpose-built HIPAA-eligible services, HIPAA-eligible relative to the US, but it's really a set of services that meet those core privacy and security controls that are required for the privacy regulations worldwide, right? And just real quickly, we have these set of services. For example, Amazon Transcribe Medical. This takes speech, converts it to text, whether you're recording a doctor's conversation with a patient, whether it's a recorded clinical note. There are various custom models for the healthcare industry, radiology, oncology, general practitioner, et cetera, in order to optimize the accuracy of this transcription. We have Amazon Comprehend Medical, which we'll go into a little bit more deeply shortly. And what that does is it helps you understand the medical context of this free-form unstructured text. This is your natural language processing for healthcare input. We have Amazon Recognition, which can extract text from images and from videos, and you could use that text. You could, for example, if you had an X-ray, you could extract the text, use the other tools I just mentioned to identify the PHI, and then obscure that PHI so that you can anonymize that data for your analysis use further down your analytics pipeline. Amazon Healthlake, which we're going to focus heavily on here in a couple minutes, it's for storing and transforming your clinical data. It is your clinical data store. And then finally, all the full stack of AI ML tools from AWS, Amazon SageMaker, and all of its associated components for analyzing, building, and training models. So when we think about Amazon Healthlake and these tools, you'll see in this stack here, this AI ML stack from AWS, that Amazon Healthlake, Comprehend Medical, Transcribe Medical, these are specialized higher level services. They're doing a lot of this undifferentiated lifting that everyone has to do who wants to store their clinical data, who wants to do natural language processing on their clinical notes. That's common. And they're wrapped in these fully managed services from AWS. So they scale appropriately so that users of this, such as ITTStar, have the ability to focus on the solutions, right? So when we talk about Comprehend Medical, what we're talking about is the ability to extract named entities from the natural language text and bring it into the system in a way that the downstream processing can handle easily, right? So for example, if this sentence here, patient is a 62-year-old female with a history of type 2 diabetes, was run through Comprehend Medical, you're gonna, the developers, the builders will get back this JSON structure. And what this structure represents is what are the named entities here? For example, the type 2 diabetes is a diagnosis, and it overlaps and is connected to the date of 1/14/2019. So it gives you the name entity pairs, what the category is, and how they relate to each other. And this is important when you are going further down the pipeline to identify in these clinical notes, this free-form data, the components that you're going to use for your analytics or your analysis of a population, of a situation. The other thing that Comprehend Medical does for you, does for the developers, the builders, is it does the ontology mapping. It will return your RX norm codes, your ICD-10, and your SNOMED codes for the data. So if you were to say Vyvanse, for example, the RX norm code for that is 854852. And so Comprehend Medical gives you this information back, thus normalizing on a standard coding system the different entities that are within that text. And that's a critical step that's automatically being managed to normalize your data for your downstream analytics and machine learning process. Healthlake is, as we talked about earlier, it's your clinical data store. And one thing about Healthlake is that it is integrated with Comprehend Medical internally, so that when you put a clinical note into Healthlake, Comprehend Medical is called and the results are brought in and added to the internal FHIR resource, and I'll describe that in a moment, providing you through your standard API the information that Comprehend Medical was able to get. Now, Healthlake is built on the FHIR format. It requires FHIR as input, and it will produce FHIR as output. FHIR is your fast healthcare interoperability resources, and it's from the hl7.org, and it provides a standardized way of exchanging clinical data between organizations or within your own organization. So the goal of Healthlake, its purpose, is to unlock the potential of the healthcare data that you have at scale. So you can store easily, you can transform the unstructured data to structured data, you can search across it, and then use this data as input to your downstream analytics. Okay. So when we talk about interoperability, we're talking about within FHIR resources to normalize the schema and structure relative to patients, plans, lab results, right? Things that providers and hospital networks use. There's a whole set of predefined FHIR resources, well over 100 of them, and it's constantly changing as the standard evolves. And these represent observations. They represent conditions the patient may have. They represent caregivers. They represent networks. They represent encounters, a patient meeting with a clinician or caregiver. And using all of this data, and in the FHIR format, you can present and process the data in a chronological view. And this leads to being able to track the history of a disease or the history of conditions across the individual patients for doing your analytics and studies. So what functionality do you have with Healthlake? As I said, it's a fully managed service, so it's higher level. So there's a set of APIs for the builders such as ITTStar that use Healthlake to create and manage a data store. And a data store is a unique storage container that will contain the clinical data that you put into this individual data store in the FHIR R4 format. And on this data store, you'll have the ability to bulk import existing data or bulk export all the data from that data store. Now, you also have the ability using standard FHIR APIs that are defined by the specification to create individual resources, to create a condition, to create an encounter. You can update existing resources, you can read an individual resource, and you can delete an individual resource. And per the FHIR specification, we also support the search API, where you can do a search across your data store for specific resource types and apply conditions based on the different fields and attributes of those resource types that will be returned. All of these APIs that access the data store directly, are REST-based APIs that are bound by the standard format using the name of the resource in the URL. So what this could look like is on the left-hand side here, putting all these resources together that we were talking about in these other tools, is let's say you have a set of clinical notes that are in PDF files. You can run those through an AWS service called Amazon Textract, which will remove the text from those images. You can take that text and put it into a document reference FHIR resource and create that resource within Amazon Healthlake. When you do that, Amazon Healthlake will call Comprehend Medical, take the results and append them to that document reference resource. So the information and the data extracted from that freeform node is then available to the other AI ML tools or dashboarding tools that you may choose to use, whether it's QuickSight, SageMaker, or other third-party tools. And the same thing applies if you have recorded audio. You could run it through Transcribe Medical, which I mentioned earlier. It will go from speech to text. Take that text, put it in a doc reference, create that doc reference in Amazon Healthlake, and as with the PDF document, the data is extracted, appended to that reference, and made available. If you have to bring in data from EMRs or other services, you can construct or work with partners such as ITTStar to ingest that data, have conversions done, and have it moved into the FHIR data store. So finally, some use cases and Nathan and company will go further into detail of what they're doing here, but general use cases that drove the creation of Healthlake, as we mentioned earlier, improving the quality of care by bringing all this data together, improving population health by making all this data available in one location or across multiple data stores that can be accessed by your downstream analytics tools. Optimizing workflows by automating the processing of forms and surveys to bring that data in so it's available to further downstream workflow processing automatically. It can enable clinical decision support by using the downstream analytics as well. And finally, as a fully managed service that's scalable, as you can imagine, it can also support the health information exchanges, large amounts of data that are imported from various sources, whether it's at the state level, the country level. All that data brought together to then be shared out with other organizations in a standard normalized format. So hopefully this gave you an overview of what Amazon Healthlake is and why it was built and the types of things that can be done with it. And now I'll turn things back over to the ITTStar team. Thank you.
Thank you, Harvey, for providing valuable information on Healthlake. Nitin, can you share screen for me, please?
I'm trying. Avi, can you stop sharing the screen? Yeah. Okay. Is my screen visible to you?
Yes. Can you go to the presenter mode, please?
Yeah.
Yeah. When it comes to the ITTStar offerings on AWS Healthlake, ITTStar will help you to remove this heavy lifting for Healthlake organizations so that they can transform health data in cloud in minutes of time and analyze that information securely at scale. We at ITTStar are very excited to bring our ITTStar solution that can help medical providers, health insurers, and pharmaceutical companies with the data-driven, personalized, and predictive care with our solutions. So we have developed clinical and patient data information system for one of our client, North George Health System. So the theme of this use case is to extract information such as medication, diagnosis, and previous conditions from doctors, clinical notes, and enrich patients' records to examine the healthcare access, providing researchers additional data points for advanced analytics to improve patient care with the help of AWS QuickSight. When it comes to the customer challenges, so we have to use the integrated natural language processing and analytics to improve hospital operational efficiency and to provide better patient care. So here the real-time data was not available. So since the client was using a legacy system, we have to use the data available in the open source and provide a centralized solution for our use case. So we solutionized multiple use cases with the patient data to create a centralized platform that securely stores the patient's medical history and medication. This platform delivers the clinical deeper insights to care progressions of the patients. So using the predefined notebooks in Amazon SageMaker with data from Amazon Healthlake, we can apply the ML models to track and prognosticate each patient's goals. We can also share the HIPAA compliance data with our patients, researchers, and healthcare partners in an interoperable manner. The proposed design, which we call as a serverless data lake design. So this helps us to convert the unstructured, semi-structured, and the structured data in a single structured format, and it can be stored in the S3. And it will provide a seamless access to the data for prediction and end-user consumption via AWS Athena and as well as the AWS QuickSight. So We use the AWS SageMaker to predict the insurance amount based upon the extracted data, such as the medical condition, gender of the person, age, etc. By using the regression models to identify the estimates, which could be used for creating the actual tables to set the price of yearly premium higher based upon the expected treatment cost. So this would all help to identify the important variables which influences the insurance using the QuickSight. So this QuickSight analysis identifies the demographic shifts of hospital patients, which is essential to provide specialized care to different subgroups, as the information helps to better tailor care to the patient needs. The clinical and health information data which you are seeing on the screen, this is the holistic view. So which will help you to and this will especially helps in the treatment coordination, especially during the cross-specialty treatment. So which requires substantial medical information management. And when you move to the financial interaction analysis dashboard we have here, so this would illustrate the inpatient treatment around and health insurers who provided it, to also helps to identify the number of claims per medical condition, where the organizations could identify which area of clinical procedures require a better insurance package banding. And coming to some of the use cases that ITTStar have developed, that population health management and optimizing the health efficiency and improving the quality of care. So we'll help the health providers, insurers, and the pharmaceutical companies to ensure that there's a data driven. Okay. Without wasting your time, so I'll be handing it to the Nitin to walk through the entire process. I think you can take it from here.
Yeah, thank you, Prabhi. So without further ado, let me. Can you guys hear me clearly?
Yes.
Yeah, no. Yeah. So as Harvey and Prabhi beautifully explained the use cases and Healthlake scenarios, let me emphasize a few more points on interoperability, like what Harvey just left from there. Let me continue from there. So when you look at this chart, right, instead of you guys had more technical overview of these data being silos in different systems, legacy systems. So what I would like all of the audience to do is imagine from a patient's point of view and as well as a hospital's point of view. So consider you're a patient, you get into an hospital, right? Based on the diagnosis made to you, like maybe you're an outpatient or emergency candidate. What happens is you'll be routed to different departments. So it could be radiology or different diagnostic treatments where even lab tests could be required. So until recently, all these tests and everything were paper-based. So when it comes to paper-based, the deficiency where only one person can use it at a single time. It's not shared across. And again, with the advent of EHR, that is electronic health records, it was all still considered to be stored in one particular hospital's organization. But still, these data was not so easily available for different departments. For example, we see the pharmacy within the same hospitals, which could get some insights on the stocks, on replenishing the stocks, or which are the productive medications. That is from hospital's point of view. Even from a patient's point of view, carrying files and having different records. If you're a patient, if you're a diabetic patient from a long term, so the blood sugar levels and different things, changes during timeline. So this is one use case when you said. When Harvey beautifully said you can have a holistic view of the patient's overall view, right? So instead of a person carrying a hard file, you can all have segregated, smart way of having this data interpreted by, which is also very useful for the doctor. Instead of going through all the files, you'll have these key points to look and visualize. Imagine for a single particular patient, if it's so difficult, all its data, for an hospital to manage such huge data of such diversity, it becomes chaotic when it comes to auditing and elsewhere. So let me quickly show you what this HL7 does and how these data actually look in real world. all those resource types, what Avi just said, right, which is the basic building format of FHIR format. These are not just your SQL metadata kind of a thing. It has a deep mapping within each other. If you take, for example, I can show you a patient's data, which is there. These are all EPA constraint and encrypted. Slowly, I will also open the console and show you how Healthlake works and how to import this data within the Healthlake and you export it, and where encryption and EPA is applied there. So if you take, for example, if you take a person or a patient, it will be identified with his own unique ID, which can also be searched within the claim. I'm just showing you the bindings, how these different data come together. So if you just understand this particular relation between why these resource types are required, then we can move ahead and talk about HL7. HL7 is Health Level 7, which was a non-profit organization started in 1987, I guess. So HL7 meaning nothing but they've taken the 7 layers of OSI open model. So indirectly they say like the data is still available to the application level, the top layer of the OSI model. I would like to also give a small real world example which they used. Let me just read out from client testimonial who they. The more the standards are integrated into the medical records, that is EHR, legacy systems, the smarter the healthcare organizations and patients become. The FHIR Organoid project, getting patient records onto patients' Apple iPhones, is a big implementation success. Now, we can see from where how the data was silos within a EHR, which is even available to a patient's Apple iPhone. So now you know how easily the data is being transferred across different regions and different devices. But again, you have to consider the patient's privacy, right? So that's when HIPAA and FHIR comes into picture, where these resource types, as I said, it keeps growing, and the FHIR health care data is broken down into these categories such as patients, laboratory results, insurance claims. And these categories are represented FHIR resource, which defines the component data elements, constraints on data, and data relationships that together make up an exchangeable patient record. This is what we were talking about all this while. And let me show you if you see the same thing as patients and diagnostic reports, everything comes as a resource type here. So without further ado, let me just get into the console and show you guys what it is. So this is the homepage of Healthlake. So I've already created the Healthlake, but Healthlake data store, because to start up, it takes around 20-25 minutes. So I'll also run you through how to do a test. I can just spin up another one that does not use this, but just for you guys to know. So we also have a FHIR format, which we can use as a preload sample, but which gives, Cynthia, there is a simulated patient's data and KMS key. So this is the part where you can see how safe and secure the data which is coming inside AWS is going to be. It's because it's not a normal, just an encryption key. It's key managed by AWS. And I'll also walk you through when we start importing the files or exporting, how to create this KMS keys and what are the different types to secure all that. So let me create this one and also show you how to import and export. So this is whenever you create a Healthlake data store, it comes with a data store ID. And this ID is useful to identify in terms of import jobs or export jobs. You need to run it through commands to find out the job status and running and associate it to it. So when you do import, what exactly you do is you gotta give a location where all these particular NDJSON files, that is FHIR format files, which is already whether you can get it from a plugin or convert it from a legacy systems in hospitals, or you can what we did, we got it from HL7 Mimic 3 data sets, where they were more resource files, actually more than this. So give this format, upload this in S3 bucket, and I'll just show you where it resides and how to get it done. So import is a folder. Within this folder, you can see all these JSON files which was loaded, and I'll just give those folder name. And once it imports, we'll see we also have to give output location where this import files, where we can see if all these import files were successfully imported or did it fail. So to create a manifest folder where we can see those failures, if suppose the failures might occur in case if suppose a resource type is not accepted by Healthlake, or if there is some data issues, it's not cleansed properly. I can't say cleansed as of now. Maybe it's not organized or structured properly in very high level. It won't take too much of complexities in that. So let me choose this. And this is where when you start doing your import job, you will have to create a new KMS key, which I will just show in the next few slides when it comes to what are different types, symmetric and asymmetric. So usually asymmetric is more secure, but here as for the workshops constraints, I'm going with symmetric, where symmetric is nothing but it has the same key to encrypt and decrypt. We need not have different public key and private keys for that. Let's make sure it's created. And I'll attach it to the roles it should be using. Sure. And get back and let's see if it's showing up. Yeah. So this is the KMS key which we created, and we are attaching it with the import job. So let's create a new one and give this. While this job is running, I'll also show you the difference. If you guys remember what Avi just said about document reference resource, right? Where these clinical notes and other physicians' prescription or whatever PDF formats or written data from a doctor, which will be stored in a particular resource called as document reference. And only that particular resource, let me just copy the import ID from the job. And this is just a command to check if the process is done. Down the lane, if you also want to check the job status and do code operations, you can use a console shell. Let me also make sure if it's the same data store ID, which is required. Okay. And I've already opened up the cloud shell. By that time, I would also show you which is the document reference that you're talking about. So this, before the export from AWS Healthlake, the import file is going to look like this. It just has encrypted data and attachments, which is not going to be displayed very clearly in this because there are links and privacy issues. So all these will be stored in the file server, which will be later retrieved while doing this process. And these things will be these prescriptions of what are the details, detailed prescriptions that has been referred in this particular resource file will be sent to this medical component, and where this NLP and ML machine learning model, which gets deep insights on entities as he explained, the IC norms and different norms will be executed. I will show you practically the addition of data which it produces post this. So if you see the import file has around 11 MB of data, that once we start doing the export, we'll be able to see the, let me just check if the import job is done. Still running. Just We go to the import and just check manually if the import output is done. Yeah, if you see with the job ID that is starting with A7 and the ID of the data store, we have an import subfolder where we get this metadata, whether the success, if there was any failure while getting these resource files, it would show there are failure resources. But I think almost all of our files have been imported within the Healthlake system. And if you see again here, I could show you the document references as around 11.4 MB of data. Let me also show you how the Healthlake can query this data, find the different resources attached to it. Let me just run a quick query with read. Grab any ID. These resource ID key IDs will be mapped in the backend for particular medications or something. So here you can also update, create, and delete. You can see all these post methods or get methods you can use to manipulate the data. And this is how you get all these details. This just shows that all the data has been successfully imported to our Healthlake. So let's do the next job. What can we do from here is to make this data be available for our analytics and any other machine learning model which we have to do. What we have to do is export this data from Healthlake to our AWS system. So let's do that. Again, we can define just the output location where we can find all this data. We give this bucket. And if you remember the same key as KMS key which we used to encrypt, we'll also create it. We'll use the same to decrypt as well. Space. So once these export job starts, we can see how the data will be available in Athena. From there, you can get going. For getting there, let me also show you guys about Glue. If all are new to this AWS system, AWS Glue, what it does is it's gonna crawl through all these NDJSON files which we just exported, and it's gonna create a metadata, and so that this metadata can be used for us, in Athena to query all this. So we need not explicitly mention the data types or data structure in order to do the ETL format. So we'll also be making use of Glue crawlers to get these exported data into our Athena. I'll show you let's make sure if export is done. Yeah, it's done. All these data from the Healthlake has been exported. And I can also show you the document reference where all these clinical notes, like from 10 MB, you can see the increase that goes up to, 10 times also, depending on how many files have been added into that file server. It's the same document reference, but only difference is it has passed through that medical component. Let me quickly show you how medical component works as well. For that, let me take a real example from the import file where we have this medications. Let me pick one. Is there an medication request? Okay, let me copy this particular. So this in AWS, if you see, this is again a standalone service, but this can also be used. This is Healthlake is incorporated with this particular service as well. So let me just quickly show you how this particular sentence can be analyzed. So it's a small analysis which even we have used in our analysis. It gives you the dosage and whether the tablet is suitable for that particular diagnosis. All these analysis I can show you in our set analysis. So let me quickly get into this export file and make the new job run. Let me create a new database so that you can see if how this works, data transformation. Let's make sure the database is created and take one and refresh this. Update it with a pre-run of Cloud and I can run this. Meanwhile, I can show you the data, if the database has been created within the Athena. Yeah, once the glue job finishes, we'll be able to see all the data. So I'll show you the clients, one of our clients' data, like as you said, we got it from the fire resource, just using the word because their nomenclatures is that's what we use here. So it's there in this case. So this import and export data, once we get out from the Healthlake, what the way we're gonna look the table is, I'll just show you in a few seconds. It's not gonna be a very clear manner for you guys because you're not aware. As of now, you guys might be aware of fire on SQL or dot operators which you can use to query these data. So what you can consider now is if you guys have used Python, it's just a JSON array kind of a fields which is in. Okay, to look at it now, it might look like unstructured, but there are particular for this. I'll have to just quickly get back to my presentation and show you what it matters and why it is that way. Yeah, so now what is the problem in being querying this directly from that Athena database? Because it's not relational. The data is not relational. It's not a normal SQL database which you can find the data just by having a primary key, because the resources are linked with each other and we don't know the complex graph. If you see in a real world, these are the different. This is how it could look, coming from the diagnostic reports. That report can lead to another test result. And all these mappings makes it very difficult for you to use a normal SQL. So what option was given? There are different methods. Either you can go and use your regex patterns and everything, but easy or most, what to say, a standardized way, what Fire used was to use SQL on Fire. It could be very intimidating for you guys to look at it now, but it's just like querying or indexing using the same SQL queries, but only difference is you use dot operators. If you see, I'll show you how these tables are also being created from our data engineers who worked on this. So to build this patient data, I'll also show you the difference, how it worked from going from totally unreadable to a readable. So this is one particular way how we used to query this unstructured format using indexes, dot operators, and slicing methods. If you see, once we ran this, like these kind of, we just collected what are the data which we require to showcase in our analytics and show you the finished product of this. So in this way, what we did is we collected whatever information is required for us and made an intermediate tables which can boost or serve as a ETL, end of the ETL pipeline to our analytics and QuickSight dashboards. Let me show you post this process from the exported data of all these resources, how we used SageMaker to build. SageMaker, again, it's a service which uses notebooks with deep learning packages, or even if you need computing powers, everything, it's serverless, and you guys can build a model, test a model, give hyperparameter tuning, and there's automation for that as well, and use it for data analytics as well. So we read this data directly from Athena, collected this data, made a baseline analysis. You see, checking for nulls, null values, and did few feature engineering in terms of date to get our months and years correct for a visualization. Did baseline again gender wise, you could see what other things, and maybe age wise. These steps are required for us to understand what kind of analytics can be prepared with the data what we have at hand. And I have not much time to go through all these explanations, but I'll give you just points on few things. So we also grouped cities based on county. So I'll show you one such thing. So all these cities were also grouped to counties, and to make this population health index, right, to understand, as RV already said, if you're living in urban or different places, how these values can be given, what hospitals can do, and providers. All these were done, but the use case, what we again did in terms of predicting was the claim amount here. So the only strong data as of now, because it was limited resource types, we could just use preview or explain. We used the providers and institutional types, and we did. And if you see, even in the heat map index, we got a 2.26 correlation with claim type institutional. So that regarded as a strong feature for us to work on our model. Then we trained the model, tested the model, and I'll show you, this was the training, how it seems to be, and tried to reach RMSE score. A couple of iterations went again, and we were able to get a decent result. And post this, let me quickly go through the analytics. So that part which I showed you in SageMaker was how you can build predictive models. Why I told you guys to see in your perspective from a hospital or patient's perspective is so that you can build apps based on these data which is available. Let me just quickly go through all these dashboards. If you see for the patient's timeline and all these we can get to know the analytics of the patient, from which what's his race type, and these are initial analysis based. Slowly we can cluster these data types and make a high level analysis as well from this, and postal code, count by records, by city wise analysis we could do, and few devices, which is also a resource type which you can also provide this data to device producers from an hospital if they are purchasing which patients prefer or being prescribed by a clinical perspective. So another very interesting analysis what we did was allergies based. So we could see in a particular season of the month, maybe the spring, there is a huge rise in the allergic types, and there was one beautiful dashboard where you can see the reactions to the particular allergic substance. Let me see what happens, like vomiting or different kinds of use cases, which you can see if you're allergic to peanut, what kind of reactions you get. All these data came to us through these resource types. If consider if we didn't have such resource types or something, it will be very difficult for us to get all these different data coming from different point to put it in one place like Healthlake and derive meaning out of it. So Fire does a lot of hard work in this, as well as AWS does much more in translating this and keeping it available for us to work on such analysis. So then conditions, vaccines, the tablets, what can be used. Also, we told this can serve as a lead to pharmacists or other county, surrounding pharmaceutical companies or retail stores, so which can also increase their supply and demand, which can also work in that way. Financial insurance, these also were shared by Prithvi in the slide. So these things can be shared with the insurance providers. If you see in our use case, the most top insurance provider was Medicare, and how they had their different promotions and on different what to say, can't say promotions, it's called different schema for different particular health insurance which they can provide, and how are these insurance covered by the people or the patients there, and how many have those insurance and how many don't have. So again, these numbers can be targeted. There are n number of ways you can. It's left to your imagination on what is the need. Again, there is also a need from the client, what it has to be satisfied. And if you guys have anything in your mind also, you can start giving the data to the patient wise and connecting it to different applications and work on it. I think that's my end. So I hope you guys understood. I just had to rush from starting to end because it's a deep concept. We'll also try to provide another session where we can go in depth and see how this data can, from start to end, can be more beautifully explained and analyzed. Tunga, thank you guys. Thank you, Avi. Thank you, Prithvi. Over to you, Ratna. If you want to start with the Q&A sessions, you can go ahead. See this. Guys, can you hear me?
Yeah. Thanks, Nitin. Thanks, everyone. We have few questions from audience. Let me read it out for you. Can you all hear me? Am I audible?
Yes.
Yeah, we can hear.
So how do we track the usage metrics of all instances? Should we have a dedicated separate resource on that? Nitin, Prithvi, and Rubek, would you like to answer this?
It was not clear. How do you track all the instance?
I repeat.
Healthlake data stores?
How do we track the usage metrics of all instances? Should we have a dedicated separate resource on that?
So instances, when you say what instances here, because Healthlake, it runs by one instance itself. So we not, Avi, do you want to take this up?
Sure. So another question is, the charts, are they from the open source data that we gathered?
Yes, sir, the synthetic data, this was built, from the open source data and this is simulated Cynthia data, which because again, if you want to get in from a real world scenario from a client data, we have to work on converting these data from a legacy system into this file source format, right? We just started the input from Fire data. So we didn't cover the part where this data coming from an hospital or provider, which gets converted into this Fire format. So that's where we can also work on that, or there are different providers from AWS as well who can work like a plugin to mapping. As I showed you, there are different mappings which has to be done before it it resides in this Fire form.
Sure. Thank you so much. The next question is it risky to convert my existing data? Can you please throw some light on risk factors? Anybody like to answer this?
Yeah, in that case, I would say risk. What are we looking at here? It's because unless we have a device connected to, see now, if you see the future, even the Apple Watch, what you have, it's going to continuously send in the data See, most of the data, it's gonna help you only, right? In terms of getting you more insights or making human life very comfortable and easily accessible to things what is required. When it comes to risk, again, I've showed you the KMS key inscription, and it's also from IPA Act, right? So it's completely safe and secure. That is a whole procedure, because there's an association with which deals with such standards, what has to be shared and what not to be shared. So all these are completely taken care by the IPA Act, which is also compilable by AWS services. So that shouldn't be risky up until now. That's what I would say.
Some additional risks you may run into that you need to work with your quality and assurance team on and your legal teams are, if you're talking about existing data, do you have the appropriate consent from the patients to use that data in future analysis? And that's something that you need to work out on your side based on the consent language that you used. The only other risk I could think of is that if you're converting or transforming data from one format into FHIR R4, that you or the partner you're working with has done the due diligence to ensure the accuracy of that conversion and has the appropriate fallbacks in case of errors that require human interaction to ensure that the data you have downstream after the conversion for your analytics is accurate.
Sure. Thank you so much. Let me take the last question. Can we integrate with existing analytics? Anybody like to answer this?
Existing analytics. Can you integrate this with existing? This, when you say, what does this mean?
Can we integrate with existing analytics?
You mean like Power BI and tools like that, right? Okay. So that's what I showed you, right? The whole process of getting this FHIR on SQL is to get the data in a normal format. So the QuickSight is nothing but it's similar to Power BI and Tableau and other resources also. So once the data is available in the required format after SQL queries, which we did, it can go on from there. It can be embedded in the present analytic tools, whichever is present.
Sure. Thanks. Thank you, everyone. That's the end of Q&A session. I'm sure audience might have enjoyed it too. So that was an informative session on health data management and the role of Amazon Healthlake in simplifying the process. Thank you, Harvey, Nithin, and Prithvi, for sharing your knowledge on the topic with us. I would also like to thank our wonderful audience for staying with us throughout the session. For further clarification of your doubts on Amazon Healthlake, do write to us at inquiries@ITTStar.com. We look forward to joining you next time with another interesting topic. Till then, have a great time.
Thank you.